the end of this lesson, you should be able to use a graphing calculator to determine the quadratic equation from a set of points using quadratic regression. This is similar to linear regression done in Algebra 1. You can make predictions using a quadratic regression model. Without further ado, let's look at an example. Here we've got the state of Georgia, in particular Atlanta. We're going to look at the air quality index, which measures the pollutants in the air, namely 5 specific pollutants. Ground level ozone, particulate matter, carbon monoxide, sulfur dioxide, nitrogen oxide. Based on these, there's an AQI, or air quality index. The table here shows the number of days in which the air quality index was greater than 100 in the city of Atlanta. Notice that anything over 100 is considered unhealthy, either unhealthy for sensitive groups, unhealthy for everyone, very unhealthy, or even hazardous. So, the first thing we want to do is sketch a scatter plot. Remember that we plot before we do any calculations. We need to do this so that we can look to see what kind of data does it look like. Now, to create a scatter plot, remember that, hang on, I'm going to find my little calculator guy. Oops. Let's see if we can go all the way down to Wabbit. And okay. Hang on, I'm going to pause this. Okay, sorry about that. Here I am back. I had to find my calculator on my computer. We turn our calculator on, clear it, and we're going to do a scatter plot. So the first thing I'm going to do is I want to enter my data. So I hit Stat, bring up Edit, and I hit Enter. I'm going to put my X's in list 1 and my Y's in list 2. Now when I do this, I'm not going to put 1990. That's a big number. Instead, I'm going to use 0 for 1990. And then I'm going to use 2 for 92, 4 for 94, 6 for 1996, 8 for 1998, and 9 for 1999. Basically, I'm going to say I'm starting in year 1990, and that's my year 0. And I'm just going to count up from there. This helps to keep our quadratic equation nicer, a little easier to work with, smaller numbers. Now in 1990, which was year 0, there were 42 days where the air quality was over 100. Then there were 20 days in 92, and there were 15 days in 94, 25 days in 96, 50 days in 98, and finally in 1999, which is year 9 from our year 0, we had 61. Now I have all my X's and all my Y's. So now I need to go and set up my scatter plot. See this where it says statistic plots? It's in blue. So second, Y equals, brings up my stat plots. I want to turn this first one on, so I simply hit Enter and I say on. Everything else should be set up. This says it's a scatter plot. X's are in list 1, Y's are in list 2. Down here you can change your mark to be anything you want. It'll look like this box, a plus sign, or a small tiny dot. Your choice. To graph this, I'm going to hit zoom, and if you go all the way down to 9, you'll see that it says zoom stat. So zoom a statistics plot. You want to zoom stat because this way it will take the data all the way out to 61. It figures out I need to go all the way out to 61 so that you'll see all of the data. Now looking at this, it does appear that it's quadratic. It doesn't appear linear because I've got a point up here, point here. It looks like it bottoms out and then it's going back up again. So your statistics plot looks like this guy. Years since 1990, days air quality index is greater than 100 is on the y-axis. So again, you can do it either way. Oops. Okay, this is the same thing as this. Now, the pattern does appear quadratic like a parabola, so instead of doing linear regression, we're going to do a quadratic regression. We already have our data in the calculator. So all we have to do is press the Stat button, go to Calculate and Quadratic Regression. So we press Stat, we're going to arrow over to Calculate, and then here number 5 is Quadratic Regression. X is in list 1, Y is in list 2. And remember, I can come down and I can store my equation. I want to store my equation in a variable, so vars, in a Y variable, so I arrow over, and it's a function, so I just hit enter, and I want to store it in Y1. This is just so later on, if I want to make a prediction, it'll make life a little bit easier. I come down and I calculate. Now, it tells me ax squared plus bx plus c, where a, b, and c are the following values. Notice, I'll bring up my calculator again. Notice that a, if I round it to 2 decimal places, is 1.76. The b value, negative 13.32. And the c value is 41 when it's rounded to the nearest 100th. So here's my equation. Now I can use this equation to predict other air quality index values. Does the equation match the graph? Well, if I graph it, it looks like this. Looks like a good match. Remember, I told you that you wanted to store your equation? Well, if you stored your equation and you hit zoom, zoom stat again, you'll actually graph that stored equation. And it does look like a pretty darn good match. All the points seem to be very, very, very close to the curve. Now, if I want to use the quadratic regression equation to estimate the number of days the air quality index was greater than 100 in different years besides the ones I have, well, 1995, 2002, 88, a couple of different ways I can do that. I can take, and 1995, let's make this a different color, is 5 years after 1990. So I put a 5 in, I evaluate it, and I come up with 18 days. 2002. Remember that you have to think 1990 to 2002. That's 12. So I put a 12 in every place where there was an X, and I evaluate, and I get 135 days. 1988. I can do 1988. That just happens to be negative 2 years. It's 2 years before the data that I used to come up with my curve. If I plug in a negative 2, I get 75 days. Now realize that an estimate based on values within the collected data's domain is called interpolation. Interpolation, inside, within. Extrapolation, think of that as extra or outside the collected data's domain. Now notice, plugging all these numbers in, that can be a bit of a pain in the rear end. You still have to figure out the X value. However, a couple of things that you can do with your calculator. I can do second calc, and I can say I want a value. Hit value. When X is equal to 5, I can hit enter, and it'll run along here and tell me 18.33. That's what we got. I can also then do second calc and say a value, and I want to plug in 12. I hit enter, and I go to, 12 is not, no, 12 should be on here. Okay, that's interesting. Invalid. I'll come back to that. Let's see here. Stat. It should be on there. Hang on, let me just double check a couple of things and I'll come right back. I figured out my problem. I just didn't want you all to have to wait while I was looking at things. From the graph, I looked at my window. In order for the value to work, my window has to include that x value. Notice my window only goes up to an x max of 9.9. I'm also going to want to do negative 2. My x min is negative 0.9. So I'm going to change this and call it negative 2.5, enter, and I'm going to tell it to go up to 13. This way it's not necessarily zoomed just on my statistical data, but the graph is now big enough to take all of my predictions. So now I hit graph, and notice it graphs it again. I still have the curve. Now I can do my second calc, and I can hit enter. Now if I put in 12 and I hit enter, it finds it, and it tells me 134.26. I have 135 here. Why do I have 135 and this says 134.26? Well, recall when I did my equation, I rounded. Okay, I rounded. Instead of being 1.75 on and on and on, I rounded it to 1.76. That small rounding error is what bumped this up some. Remember that these are predictions, and while they should be plus or minus a tenth, depending on where you round and when you round, you may be off by just a little bit. Now we did fix our window, so we could also do second, calculate my value, and I want to check for negative 2. Negative 2 is 74.68, which does round to 75 days. Now, when we talk about this, remember that our data was from 1990 to 1999. So for interpolation, I have interpolation here, and I have extrapolation here and here. Extrapolation is outside of my data gathered. Interpolation is within. Which one is most reliable? Usually interpolation. Something could have happened either earlier or after the data was collected that might dramatically change the outcomes. If it's within the collected data's domain, usually any major event affects some of the data surrounding your particular prediction. So interpolation is the most reliable. If we have the following data from the National Health and Nutrition Examination Survey about the adults who are overweight or obese is increasing. These are the years since 1960. We want to use quadratic regression. Pause the video and try figuring it out yourself, seeing if you get the right equation. Then when you're done, unpause the video and watch to see if you did the right things. Here we are. We're going to edit our lists. We're going to go up first and clear each list. And then we're going to enter our data. So for here, we have years 1, 12, 18, 31, and 39. Going to go with those data, we have 45, we have 47, 47 again, 56, and 64.5. I have all my data in. My X's in list 1, my Y's in list 2. X's are the number of years since 1960. The Y's, it's the percentage of Americans who are overweight or obese. Now I hit stat, and I can calculate, and I can hit enter. Whoops, except that was wrong. Stat, calculate. I want to come down here and do quadratic regression, and I'm going to come down. I'll store the equation, so I hit vars, arrow over to y vars, hit enter function, enter y1, come down and calculate. Here's my equation. 0.017 minus 0.174x plus 45.493. Here's my equation. Now, we just assumed this was quadratic because that's what I told you to do. But remember, we should check what it looks like. So if I do zoom 9, that will give me a statistics plot, and I can look at the data and I can look at the equation. And it does in fact look like it matches our quadratic. I didn't do the scatter plot first. If you're told it's quadratic regression, you can assume it's a quadratic model. If you're not told what type of regression, you have to do the statistics plot first. Parabolic data can be modeled by a quadratic regression equation. Predictions are made using that regression equation by substituting values for either the x or the y and solving for the other value. Predictions made within the collected domains data are considered interpolation and are generally fairly accurate. Predictions made outside the collected domains data are considered extrapolation and may or may not be very accurate. The further it is away from the collected data's domain, the less accurate the prediction generally is. Not always, but generally. That's a wrap.